Hello everyone, Mr. Hansen again. This is a little tutorial on what a fraction is by definition. The biggest thing you have to remember when you're talking about fractions is you first have to define what one whole object is. For example, right here on front of the screen I have this hexagon. Briefly, I'm just going to describe that as one whole. So that's one unit. And the question is, well, when we talk about fractions, we're talking about parts of a whole. Sometimes we're looking at parts that are smaller than the one whole. In other words, in this case, smaller than this yellow hexagon. And sometimes the parts will be bigger than this yellow hexagon. But we're comparing it always to this one hexagon, and that's the key. Another example might be, you've all seen these, money, right? You might define the whole to be a dollar bill. A dollar bill would then constitute the whole, and a quarter would be, well, let me ask you, how many quarters are in $1? I hope you all agree there's 4, right? So 1/4 would be 1/4 of a dollar. 1 penny would be how much compared to the $1 bill as the whole? It'd be 1/100th of a dollar because there's 100 pennies in $1. Think about a dime. Dime is 1/10 of a dollar, and nickels would be 1/20th. So, as you can see, it's very important to start out with something that you're going to define as a whole. So, if this is a whole object, 1, can someone tell me what this red piece in comparison to the yellow piece would be representing? And I think you all agree that that would be half of the yellow piece, right? So in this case, the red piece is 1/2 of the whole. If I want to, I can put the other half there, and you can see visually that 2 halves make 1 whole. Okay? Next, let's take a look at these pieces. Before I fill them all in, can you visually see what fraction the blue part represents? If you said 1/3, you are correct, because it takes 3 of these to fill in the whole object. So that would be 3/3. Okay, 3/3, and we're going to talk about equivalent fractions. 3/3 is the same thing as 1. If I take one of these away, what's represented now with blue? If you said 2/3, you are correct. Okay. One last one. I'm going to stick a green triangle on here. How about now? What does the green triangle represent? What fraction of the whole yellow piece is that one green triangle? I'll give you a second to look and visualize. Okay, well, again, if you said that represents 1/6, you are correct, because again, it takes 6 of these to fill up this space. I got one more to put on there. And there you have it. Okay, so 6/6 is the same thing as a whole. Alright, so that just gives you a little background. The key, I can't stress this enough, is to identify what the whole object is. Because, for example, what if I add another hexagon, and now I'm going to define this to be the whole thing. Okay, it's no longer just one hexagon. The whole thing is now 2 hexagons put together. So the question is, before, remember, that represented a half, but now how many of those red pieces could I put on all those yellow spaces? Now in this example, these red pieces are no longer a half, they are a 1/4. And again, it's because I've redefined what the whole object is. So this would be, if I take one away, this would be 3/4. Okay, if I take this away, it'd be 2/4, and we all know 2/4 is the same thing as a half, right? And this would be 1/4. Okay? Alright, now, remember this was 1/6 of the original one hexagon. Now that we have two hexagons defined as the whole, how many of those little green pieces do you think will take to fill that? Okay, well, if you're quick on your feet, you'll realize that we'll still need 6 to fill one, but that's not going to cover the whole object. It's only going to cover half of it, so we got to add 6 more green ones over here. So the green pieces, if we define the whole to be 2 hexagons, is now 1/12. Okay, did the best I can there. So 12/12 is the same thing as one whole object. All right, let me just briefly talk about adding fractions because a lot of us still have problems with this. And I'm going to now go back. We're now going to go back to the original definition of this one hexagon being 1 unit. Okay? So here's my question. This represents 1/6 of this, right? Here, let's do it this way. And I want to add that 1/6 to this 1/2 I have over here. So I want to add the green and the red pieces together. Well, how do we do that when they're different shapes? And that's the dilemma we run into when we add fractions. We can't do that. It's impossible. It's like adding an apple and an orange together. It doesn't work. So what we have to do is find a common denominator. In other words, we're going to slice these shapes into shapes that are exactly the same size so that we can now find out how many there are. And what I mean by that is this. Let me just do this as an example. So we have 1/2. Let me grab a pencil quick. Thanks for your patience. Okay, so this represents 1. This marker's kind of seen its day too, I see. 1/6 plus 1/2. Okay, this is the problem we're trying to work out. 1/6 plus 1/2. Well, you can see that the denominators are different. Remember, denominators are the numbers on the bottom of the fractions. We're trying to add these two pieces. Well, they're not the same size and not the same shape. So what we do is we try to find a common denominator. Okay, we try to find a common denominator. Okay, so if you can see now, the area represented by the green, the 3 green pieces, is the same as with a 1/2 piece, the red piece. But look, we haven't changed the values of the fractions. This is still 1/6. This is still a half, but now instead of writing it as a half, we're writing it as 3/6. Why 3/6? Can anybody tell me? Well, we're now talking about 6. There's 1, 2, 3 green triangles. Okay. So once we have that, now it's easy. We can add 1 plus 2 plus 3 plus 4. There's 4/6. Okay. The bottom number tells you the size of the piece. If this number is bigger, that means we're looking at smaller pieces. If the number is smaller, like 2 or 3, that means these pieces would be bigger. Okay? And 4/6, if you remember, we could treat that as 2/3, right? Reduce the fraction. Let me demonstrate that. Okay. Remember these blue pieces? Okay, these were representing 1/3 before. 1/3 of the one yellow hexagon. Well, if you look at this, let me get rid of all the stuff except the 4/6 that we have here. Okay, just to show you that 2/3 is the same thing as 4/6. Here's 2/3, and here's 4/6. The question is, are those areas the same? Well, the only way to find that out is if we put them on top of each other. And it looks to me like we're going to have some success here. So this is a demonstration to show you that 2/3 is the same amount as 4/6. I hope that helped you with a little bit understanding fractions.